Hello, welcome to the course of IPv6. So today we are going to discuss about the routing protocol of IPv6. So here in this chapter we will discuss about the two protocols, that is RIPNG and OSPFv3. So let's start with first, that is RIPNG. So here the RIPNG is known as Routing Information Protocol Next Generation. So in IPv4 we will use this RIP only, but in IPv6 we will discuss about the Routing Information Protocol Next Generation. And this RIPNG is based on the distance vector algorithm, as IPv4 RIP is also based upon this distance vector algorithm. So here the concept for RIPNG is taken from RIP version 1 and RIP version 2. And it is specified in RFC 2080 in January 1997. So here RIPNG used the distance vector algorithm. So let's discuss about what is the distance vector algorithm. So here this mechanism will calculate the cost or metric of a route. It means it will count the number of hops that are the intermediate between the source and the destination. So here the RIPNG will support the maximum of 16 hop count. It means a packet that is transmitted from source to router will only cross the 16 intermediate devices that are present in between the source and destination. So the distance that is greater than 16 hop count will be considered as unreachable. And here the convergence time is a time that is taken by a device to know about all the routes in a network. So here the hop count is a count that will count the number of routers and that will present when packet will reach from source to the destination. And here the router will periodically distribute information about its route to its directly connected neighbors using RIPNG response messages. So this is the distance vector algorithm. It will calculate the cost of the route. So here the limitation of RIPNG, we are not using this RIPNG in IPv6 because it has some limitation. So the first limitation is the network area is limited, or there is a small network area. So the small network area is due to it can only transmit a packet to a 16 hop count. And next one is the presence of routing loop. So here the presence of routing loop in a network will cause a increase in convergence time and it will make the system unstable. So here the next limitation is it doesn't measure other real-time parameter such as the link load, reliability, delay. So these are the parameters from which we can judge the network is good or not. So here in our IPNG it is not using such parameters to measure such parameter to create a better route. And the last limitation is that any change in the network structure will cause the instability in the network. So to overcome some of the limitation, the first one is split origin. So here it introduces a two part, that is first one is split origin. Here a router will never advertise a route back over to its next hop interfaces. And in split origin with poison reverse, here a router always advertise a route back over its next hop interface with a metric of 16. So these are the two concepts that are used to overcome some of the limitation in RIPNG. But we are not using this RIPNG routing protocol in IPv6. The next we introduce the OSPF, that stands for Open Shortest Path First version 3, and it is specified in RFC 5340, whereas in IPv4 we are using the Open Shortest Path First version 2. So the fundamental OSPF mechanism and algorithm remain unchanged, but the packet and link state algorithm format are different in OSPFv3 and OSPV2. So here this OSPF is introduced to eliminate the limitation of RIPNG. So the limitations such as it has a small network area, it will use a high convergence time, and it has a low metrics. So it will eliminate these drawbacks from the network. So OSPF consists of large routing table to accommodate large number of routers, and it will choose best path in a network on the basis of link state. So here the OSPF router will keep the information about the state of all network connection or link between the network. So as it is forwarding the packet or finding the best route by using the link state, so here the router will give the information about the network connection or the link. So in case of link failure, it also converges on a new loop-free routing structure within a seconds. So it will compute the shortest path tree for each route using the link state routing algorithm or a shortest path first algorithm. So here it calculates shortest path using a method based upon Dijkstra algorithm. So next is similarity between OSPv2 and OSPv3. So here these both protocol will use a link state IGP routing protocol, and it will use a ABR and ASBR. That ABR is the area border router, whereas ASBR is a autonomous system boundary router. So after that it will use the SPF, that is shortest path first calculation with Dijkstra SPF algorithm, and both will use the metrics that are based upon the interface bandwidth, and both will have a 5 common protocol packet time: hello, data, database description, link state request, link state update, link state acknowledgement. These are the 5 protocol packets that are used in this both OSPv2 and OSPv3 routing protocol, and they will have a same LSA flooding and aging time. But the differences between the OSPv3 and OSPv2 are like they will use a different address family, because as OSPv2 is used in IPv4, so here the address space will have 32-bit, whereas in OSPv3 it is used in IPv6, so here the address space is of 128-bit long. And next it will introduce a new LSA format, because here as the address families are different, same way we have to change the LSA format as well as the packet format, and it will run per link rather than the per subnet, as OSPF is running over the per subnet basis, but in OSPFv3 it's running on per link basis. Next, it will support a multiple instances on a single link. Interface can have a multiple IPv6 addresses. So here in IPv6, a single interface will have a multiple IPv6 addresses. And after that, the OSPFv3 is used a link local address, whereas in OSPFv2 there is nothing like a link local addresses. And after that, in OSPFv3 it will use a neighbor authentication by using a IP security, that is the field in a packet format of IPv6. So these are the similarity and differences between the OSPv2 and OSPv3. So this is all about routing protocol, in which we have discussed about RIPNG and the OSPv3. So this is all about the routing protocol in IPv6. Thank you.